All right, hey again, Honors Chemistry. I wanted to set you up on question number 3. Question number 3, there are going to be two parts. First part is getting the pressure of the hydrogen gas because you're collecting a gas over water. And then the second part is getting the moles of H2 using PV equals nRT. Okay? And so, the way that you are going to solve this first part is it says a 250 milliliter flask of hydrogen gas is collected at 763 millimeters of mercury at 35 degrees Celsius by displacement of water from the flask. The vapor pressure of water at 35 degrees Celsius is 42.2 millimeters of mercury. How many moles of hydrogen gas are in the flask? So if I want to collect gas over water, P of the gas is equal to P total minus P of H2O. That is the equation for collecting a gas over water. So my total is this. That's the total. The gas was collected at 763 millimeters of mercury. So that's my total. So 763 millimeters of mercury minus, it says the vapor pressure of water is 42.2 millimeters of mercury. If I do this calculation correctly, I should get 720.8 millimeters of mercury. And then, by the way, side note, because eventually if I need this for PV equals nRT, I need atmospheres. To go from millimeters of mercury to atmospheres, you divide by 760. So I'm going to divide by 760, and I get my pressure of hydrogen is 0.948 atmospheres. Okay, so now I have my pressure of hydrogen gas, which is 0.948 atmospheres, or 720.8 millimeters of mercury. Now I'm ready to move on to the next part where it says how many moles of hydrogen. The only way that I could go from pressure to moles is by using the ideal gas law equation. And so I'm going to rearrange this equation. N is going to be equal to PV over RT. Okay, and so I'm looking for N. I actually have a lot of other variables. I have P, which is 0.948 atmospheres, which is mentioned right here. I do have my volume, and I actually bolded it in the problem. The volume in which I collected all of this in is 250 milliliters of the flask, which is equal to 0.25 liters. My volume needs to be in liters. To go from milliliters to liters, you divide by 1,000. So just to remind you about that. R, of course, is 0.08206 liters times atmospheres per mole Kelvin. And then my temperature was already given to me. There's only one temperature in this problem, and it's 35 degrees Celsius. But my temperature needs to be in Kelvin, so this is 308 Kelvin. Now I have all of the variables that I need to solve this problem. I'm not going to show you this, but if you plug and chug this into N equals PV over RT, check to make sure that you know how to do the math, or you can plug and chug into a calculator. You should get N is equal to 0.00938 moles of H2. So check to make sure that you're doing that calculation correctly by plugging in all these values. This, and this. Make sure you're plugging these values correctly to get this number.